Number 10, factor the following polynomials. Okay, we need to get the GCF for each one, don't we? The GCF of 12 and 18 is a 6. So I'm going to draw two fraction bars under here. I could divide by 6. I could also divide by a negative, can I? They both have negatives. And I could take an x out. Remember, the smallest exponent's 1. So I'm going to take this term and write it right here. Start a parentheses. Negative divided by a negative is a positive. 12 divided by 6 would be 2. X squared divided by x would be x. A negative divided by a negative would be a positive. 18 divided by 6 would be 3. And then the x's would eliminate. If you multiply this, you'll go back up here. Okay, on this problem here, a negative, a positive, a negative. I can't take out a negative like I can over here. I can divide every term by 3. And they all have x's, don't they? So I could take an x out. Okay, now then, I'm going to take this 3x, put it right here, and start a parentheses. Okay, negative 6 divided by 3 is a negative 2. X to the third divided by x would be x squared. 9 divided by 3 would be a positive 3. X squared divided by x would be x. And a negative 15 divided by 3 would be a negative 5. The x's cancel out. If I multiply these, I get this, don't I? Okay, the last one, they both have negatives, don't they? So I can divide by a negative. If they both have negatives, you could take a negative out. 16 and 24, the GCF of that is 8. They both have x's. And they both have y's. The smallest exponent on the x would be 3. And the smallest exponent on y would be that 1, wouldn't it? Now then I'm going to take the GCF of negative 8x cubed at y, write it down right here, start my parentheses. Negative 16 divided by negative 8 would be a 2. X to the fifth divided by x to the third would be x squared. And the y's eliminate, don't they? A negative 24 divided by a negative 8 would be a positive 3. X to the third divided by x would be x squared. Y to the fourth divided by y to the 1 would be a y to the third. So remember, on these you subtract your exponents. If you were to distribute that to this, you would end up with this.